Hi, you guys. We are going to do a practice Bohr diagram, which is a drawing of the atom. We're going to use silicon 31 today. Remember, 31 is the mass number. So in order to find the protons, neutrons, and electrons, we're going to need to find silicon on the periodic table. Silicon, if we look, is number 14. So remember, the atomic number is equal to the protons and the electrons, which means that they're the same. So if our atomic number is 14, we have 14 protons and 14 electrons. Now, if we want to find the number of neutrons, we're going to need to subtract our mass, which we said was 31, minus atomic number. So that means that we are going to have 17 neutrons. So next, we need to go ahead and draw this. So we're going to start by putting our protons inside the nucleus. Remember, the nucleus is the center. Protons are positive, so I'm going to use my red positive pieces over here, and I'm going to pull them to the center. So I'm going to put 14 positive protons. A couple of things to remember as you're doing this. You want them to be tight together. They're a solid in the nucleus. They can overlap, but make sure that you can see that positive sign. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. The other piece that goes in the nucleus is the neutrons. Neutrons are neutral and they have no charge. We're going to put them tight with our protons. And what we need to remember is that they are the same size as our protons. So when we're drawing them, we want to make sure that they're the same size. Three, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. Okay, so that's our nucleus. Again, remember the protons and neutrons are the same size and they're tight together. Next, we're going to put in our electrons, and our electrons belong in orbitals. And remember, orbitals are rings around the nucleus. Our electrons are much smaller than our protons and neutrons, and so we want to make sure that in our drawing, we show that they're much smaller. So we're going to put these in. Now, another thing that we need to remember about our electrons is that they belong in certain orbitals. So what that means is that we can only put a certain number of electrons into each orbital. So I am going to start. My first orbital gets 2 valence electrons. My next orbital can hold 8 valence electrons. So I've got 2 in my first. I had 14 total, so that means I have 12 left. So I can fit 8 of those. 1, 2, 3, 4, 5, 6, 7, 8. Now notice I'm putting them as far away from each other on the orbital as possible. They don't like to be next to each other, so that's why I'm putting them so far away. So I've used 10 valence electrons, but I have 4 left. So I'm going to need to put those 4 into a third energy level. And again, I want to spread them as far away from each other as possible because they don't like being next to each other. So we've got 1, 2, 3, and 4. So that is what our Bohr diagram should look like. Got the protons and neutrons in the nucleus, and then the electrons, which are much smaller, are in orbitals around the nucleus.